In addition to electrical methods, we're going to have the radioactive methods. And we're going to look at the gamma ray lock, neutron lock, and the density lock. But before we start talking about the radioactive locks, we're going to talk a bit about physics and about the nuclear physics. All radioactive methods are based on the nuclear physics. So let's look at the structure of the atom. Everything in the world consists of the molecules, and the molecules consist of the atoms. And each atom consists of the core, or the nuclear, and the electrons that are flying around the nuclear. Electron got a tiny mass, but non-zero, and it's got negative electrical charge. Inside the nuclear, we're going to have two types of the particles, which are neutrons and the protons. Mass of the neutron more or less equal to the mass of the proton. Proton got the positive electrical charge, while the neutron do not have any electrical charge. The amount of the protons shows the chemical properties of the atom. If you're looking at the Mendeleev periodic table, we can find out that it shows us the change in the amount of the protons in the nuclear. So one proton means it's hydrogen, two protons means it's helium, three protons means it's lithium. And it doesn't matter how many neutrons inside this nuclear. For example, in case of the proton, once we got only one proton, that gives us the nuclear of hydrogen. In case if we add one additional neutron to this nuclear, we're going to have proton and neutron inside the nuclear, but it's still going to be hydrogen. There are two types of the nuclears, stable and non-stable. Stable nuclears are not changing through the really large periods of time. Non-stable can be broken. Non-stable nuclears can be divided onto several parts and emits energy in the outer space. It emits energy as the alpha, beta, and the gamma rays. We are not using alpha and beta rays because they do not have a big penetration distance. So we simply cannot measure them. But what we do use is the gamma rays. Gamma rays is a really electromagnetic wave with a really high frequency. And these electromagnetic waves can penetrate on a relatively deep distance. Gamma ray lock. This lock is designed to measure the natural radioactivity of the rock. So we simply put into the well bore a special receiver that receives the gamma rays from the rock. If we measure the natural resistivity of all of the rocks, we can find out that the igneous rocks get the highest radioactivity. Metamorphic rocks get a bit lower radioactivity, while sedimentary rock get the lowest radioactivity. But if we range the sedimentary rocks on its radioactivity, we're going to find out that the highest radioactivity get shale. In this case, we can find out the presence of the shale inside the formation. Why shale get the highest radioactivity? Because of the presence of the isotopes of potassium, thorium, and uranium. And this log, we can see two different readings. The red one shows the SP log, and the green one shows us the gamma ray log. And we can see that in general, they got more or less the same shape. And that's logical, because the high readings of the SP show us the presence of the shale, while the low readings of SP show us the clean rock. The same story with the gamma ray. high readings of the gamma ray show us the presence of the shale, while low readings of the gamma ray show us the presence of the clean rock. The main objectives of the gamma ray is the lithology estimation, correlation of the well sections, and determination of clay. The main limitation is even a small amount of the radioactive metals in the rock lead to misinterpretation. For example, in certain cases, we can have the potassium particles in the different rocks, like in polymictic sandstone. In this case, the sandstone itself can have the high radioactivity. And once you get the high radioactivity, you can misinterpret that as the presence of the shale. So you can look clearly on all of the logs, not only on the gamma ray. Another limitation is the low recording speed. Because of that, we're gonna spend a lot of time on the well to record the readings, and that increases the cost.